Hello students, welcome to the next lecture in the course Statistical Modeling for Business Analytics. Today we are going to talk about hypothesis testing. So this is how the outline of this presentation will go. First we will define the key elements of hypothesis testing. Next we will lay out the steps to conduct a hypothesis test. We will talk about one-sided and two-sided tests. Then we will talk about two criteria by which hypothesis tests can be conducted, that is the rejection region versus the p-value approach. And finally we will decide how we can specify confidence intervals for a particular population when we are trying to estimate a population parameter. So what is hypothesis testing? In statistics, a hypothesis is a claim or a statement about a property of a population. What that means is whenever you say something, you sort of assume that, or you state, you make an opinion statement about something about the population. Okay, so you say, I think this percentage of the population lies under the poverty line in India, or you make another whatever statement that the average salary got by an MBA student when they graduate with an MBA degree is these many lakhs per annum. So any statement that you make is a hypothesis. So whenever you make a statement, typically if you are a statistician, you will not allow some people to make a statement without providing data to support that statement. So the whole idea of hypothesis testing is to test any statement that is made using actual data. So there are two opposing conjectures. So the null hypothesis and the alternate hypothesis. We'll go talk a little bit more about the null hypothesis and the alternate hypothesis. But basically the null is the status quo, or what without any evidence you can say that, or even if you are making a statement about the state of the world, that can also be a null hypothesis. And the alternate hypothesis is everything but the null. And these two hypotheses are mutually exclusive and exhaustive. Mutually exclusive means if null is happening, then alternate cannot happen, and together the probability of null happening and the probability of alternate happening is equal to 1, because those are the two states of nature that are exhaustive. So we accumulate evidence, as I said, we collect some data from a sample and we analyze the sample information, and then we decide whether we will reject the null hypothesis or whether we will fail to reject the null hypothesis. So let us see some examples of hypothesis statements. So as we said before, a hypothesis is a claim about one or more population parameters. Here you will see that I have underlined the word claim and I have underlined the word population. It is a claim that you make. It is not yet verified, and it is something that is about the population. Okay. Now what are some of these claims that you can make? Say average height of an Indian female adult in India is mu equals to 170 centimeters. You make this claim. Or the mean monthly electricity bill of an Indian household is mu is equal to rupees 1500. Suppose you say that the average number of children in a household in India is mu equals to 2. So these are all null hypotheses, or these are the statements that you are making, and you have to collect data. So the null hypothesis, as I said, is always about a population parameter. It is not about the sample statistic. And sample evidence is used to assess the probability that the claim about the population parameter is true. Okay. Now what are the steps to hypothesis testing? First we state our null and our alternate hypothesis clearly. This is important. You will realize later on how we should state the null, or what is the appropriate null hypothesis to state. Then you will identify whether you want to do a one-tail or two-tail test, and we will talk about this also later on. Then you will identify the correct test statistics. So are you testing a mean? Are you testing a variance? Are you testing the proportions? So based on that, your test statistic itself will change. Then we compute the test statistic from the sample data, and then depending on the level of significance indicates that what is the level of type 1 or type 2 error you are willing to accept. When you test your hypothesis, you will be committing some kind of error. It is not that when you test the hypothesis from a sample, you will absolutely give the correct result. There will be some type 1 or type 2 error. What is the level of error that you are willing to accept? Finally, you will find the decision rule or the critical values and the rejection regions. All of these words are new to you now, but we will come to it. And then if the actual sample statistic lies between the negative critical value and the positive critical value, then you do not reject the null hypothesis, or you can also compute the associated p-values. So first step, state the null hypothesis. So what is the null hypothesis 80? It refers to the status quo. So when we said that the adult height of Indian female adults is equal to 170 centimeters, mu is equal to 170 centimeters, that is your null hypothesis. Typically, the null hypothesis will always contain either an equal to sign over here or less than equal to, even here the equal to sign is here, and greater than equal to sign. So it will always contain equal to in some way or the other, and it typically refers to the status quo. So you may reject the null hypothesis or not reject the null hypothesis. Second step is to state the alternate hypothesis. Now the alternate hypothesis is the opposite of the null hypothesis. As I said before, the null and alternate hypothesis are exact complements of each other. So in the state of the world, if you have two different states of the world, so if you have null over here, then, and this is the entire world, then this will be alternate hypothesis. As you can see, there is no overlap between null and alternate, and also null and alternate together comprise the entire world. Okay. So the alternate hypothesis typically challenges the status quo. It does not contain the equal to, greater than equal to, or less than equal to or greater than equal to sign, and it does contain the not equal to, greater than or less than sign. Okay. And in the previous case where we said that the null was mu equals to 170 centimeters, then the complement of that is, or the alternate hypothesis is, mu is not equal to 170 centimeters. Typically, null hypothesis, in hypothesis testing, null hypothesis is assumed to be true. So null hypothesis, in the absence of any evidence, the null hypothesis is assumed to be true. So basically, the burden of proof is on the alternate hypothesis. So in the absence of any evidence, we go with the null hypothesis. Now if someone wants to disprove the null hypothesis, then they have to collect evidence and show beyond doubt that the null hypothesis is false. Okay. Since the null hypothesis is assumed to be true prima facie, you can only reject or fail to reject the null hypothesis. You don't typically say that you accept the alternate hypothesis. So this is the same as saying that the innocent till proven guilty. Okay, typically when someone is accused of a crime, they are innocent till proven guilty. So the null hypothesis is that the accused person is innocent. In the absence of any evidence, typically a person will be considered to be innocent. So the burden of proof is on the accuser to prove that in fact a person is not innocent, they are guilty, rather than the accused to prove that he himself is innocent. Now, how do you draw inferences about the population? So we have discussed the sampling distribution of the mean, which is where we said that the sample mean is a random, since we cannot get data for the entire population, we try to make inferences about the population by getting a particular sample. Now, because this sample is a smaller subset of the entire population, and because it is chosen randomly, so the sample mean itself is a random variable. Had you chosen another different random sample, you would have got a different value of the sample mean. So the sample mean itself is a random variable, and it has its own distribution, which is called the sampling distribution of the mean. Now, the central limit theorem states that as the sample size increases, the distribution of the sample mean approximates a normal distribution. We have already discussed this in the last lecture, so I will not go over it again, but basically the idea is that the sample mean, not the sample variable, not the variable itself, but the mean of the variable from a given sample approximates a normal distribution. So, what we do is we compute a z score from the sample mean. We calculate the sample mean and we compute a z score. Suppose you are testing a hypothesis about the sample mean. Then you compute a z score, which is basically the sample mean minus the population hypothesized mean. So, you have suppose you have your population hypothesized mean in that particular case of the height of female adults is 170 centimeters. Now, you gathered a sample and the sample mean came out to be 150 centimeters. So, does that give credence to your null hypothesis that the mean is actually, the population mean is 170? So, you see how far, what is the difference between the sample mean that you have got and the hypothesized population mean, that is 150 minus 170. And since there is some kind of sampling error associated with x, you divide it by the sampling error of x. So, this standardized normalized variable, which is called the z score, you divide it by the standard error of x, which is basically sigma by root n, and in case of small samples it is s by root n, or in the case you don't know the population variance and you know the sample standard deviation, then you look at the sample, not the population standard deviation but the sample standard deviation. This is the z score. So, this you are subtracting the hypothesized mean and you are dividing it by the standard error of x, and this quantity that you get is called z. And interestingly, if the sample size is large, this z is distributed according to a standard normal distribution. Okay, this n01 means the mean is 0 and the standard deviation is 1, which is a standard normal distribution. So, what do? We use tables for standard normal distribution to see whether the z score is large enough for rejecting the null. Why will you reject the null if z score is large? Because your sample mean that you have observed is very far from the hypothesized population mean. So, probably the hypothesized population mean is not exactly right. The difference between the sample mean and the hypothesized mean is too large. There are two kinds of errors that you might commit when you do hypothesis testing. The first type of error is known as type 1 error. This is rejecting a true null hypothesis when it should not be rejected. So, in the case of the person being innocent till proven guilty, suppose you actually take an innocent person and pronounce them guilty, then they are not really guilty in real life, they are actually innocent, and you are suggesting that they are not innocent. Okay. So, this is an example of a true null hypothesis which should be rejected, but it was not rejected using your sample data. So, this is considered to be a very serious type of error, and this type of error is called a type 1 error, and the probability of committing such an error is known as alpha. Okay. This is also known as the level of significance of the test. The type 2 error is rejecting a false null hypothesis. Your null hypothesis is actually false and it should be rejected, but you did not manage to reject it, then this is the type 2 error. Example, for instance, guilty person is not pronounced guilty. Now, guilty is not the true, the null hypothesis that that person was not guilty is false. In reality, it is false, but you did not actually reject the null hypothesis and you allowed him to walk free, him or her to walk free, then that is a type 2 error. So, let us look at these two kinds of errors. So, basically, if the actual situation is null hypothesis is true and you do not reject the null hypothesis, then you are arriving at the correct decision. If null hypothesis is true and you reject the null hypothesis, then this is an incorrect decision, and this is known as a type 1 error or alpha. If the null hypothesis is in reality false and you do not reject the null hypothesis, again this is an incorrect decision and this is type 2 error, and the probability of committing this type 2 error is known as beta. And if the null hypothesis is false but you actually reject the null hypothesis, then again you have taken the correct decision, and this is 1 minus beta. The probability of this is 1 minus beta. Now we come to the idea of one and two sided tests. So so suppose you say, so you can make a one sided test where you just say your null hypothesis is something is equal to something else, and the alternate hypothesis is that it is not equal to the other thing. Then that is a two sided test. If you get evidence for the statistic being lower than the hypothesized value or higher than the hypothesized value, in either case you will reject the null hypothesis. But sometimes you make a more strong statement and you make a directional statement. So you say mu1 is less than mu2, or mu1 minus mu2 is less than 0. Mu1 is greater than mu2, that is you take two populations and the mean of one population is less than the mean of other population, or the mean of this population is greater than the other population, and mu1 minus mu2 is greater than 0. Here this is actually these are the null hypothesis and these are the corresponding alternate hypothesis. So suppose your contention is boys are taller than girls, then the opposite statement is boys are shorter than or the same height as girls. If you get evidence for boys are shorter than girls, then also you have to reject the null hypothesis, and if you get evidence for boys are the same height as girls, then also you need to reject the null contention, that is boys are taller than girls. This is written as an alternate hypothesis and this is written as a null hypothesis. So you have to reject both these possibilities before you can make a statement that boys are taller than girls. But suppose they are the same height as girls, in this you are not making a directional claim, then the null hypothesis will be that the boys and girls have the same height, and then you will have a two-sided test.